To Everyday Mathematics. Here at Everyday Mathematics, what we do is we go about on the run and look for interesting problems, solve them, and share with you our versions of the solution. Today, we are still on the 2024 integration, Universal Florida Integration B, qualifying round, part 3, and we focus on problem number 24, which is the definite integral from x equals to 0 to x tend to infinity of sine of x squared plus sine of x squared minus x. Before we solve this problem, I'd like to encourage those of us who haven't subscribed to this channel to please consider subscribing to our channel. Your support would really help us increase the profile of our channel. And also, if you do like what you see, please don't hesitate to leave a like and also share if you can. So without much ado, let's move forward to the solution phase of this problem. Our problem, right? From 0 to infinity, sine of x squared plus x plus sine of x squared minus x. And here we can say this is the same as 0 to infinity sine of x plus a half squared minus a quarter plus sine of x minus a half squared minus a quarter. Okay. What we have here, so this is the same as 0, infinity, sine x plus a half squared cosine of a quarter, and then this is minus cosine of x plus a half squared sine of a quarter, and after that we do have for this, which is sine of x minus a half squared cosine of a quarter minus cosine of x minus a half squared sine of a quarter. Okay, so this is the same as cosine of a quarter zero to infinity sine of x plus a half squared plus sine of x minus a half squared dx, and then we have minus sine of a quarter from 0 to infinity cosine of x plus a half cosine of x minus a half. Okay, and here we can do a couple of substitutions. So we have cosine of a quarter zero infinity sine x plus a half squared plus cosine a quarter zero infinity sine rather x minus a half squared minus sine a quarter zero infinity cosine x plus a half zero infinity cosine x minus a half squared. So from here we could say u be equal to x plus a half, and that means du dx equals to 1, and that means that du is equals to dx. And what does that mean? It means that when x equals to 0, u equals to a half, and so we have same thing for this. So we have minus sine a quarter cos rather, and then up here what we do is we say plus, and if we let u be equal to x minus 1 minus a half rather, we have cosine of a quarter negative a half infinity, and let's use the variable y. So we have sine of y squared dy, and here we have sine a quarter negative a half 0 cos of y squared. And we see that since these even functions or they're symmetrical about 0, we can see that the value of the function from negative a half to 0 is the same as from 0 to a half. So we can bunch that together to say, okay, if we're beginning from 0, then we're having twice, right? So what I'm saying here is now we have twice cosine of a quarter from 0 to infinity of sine, let's just go back to x, minus twice sine of a quarter from 0 to infinity cosine of x, right? And I will leave a link in the description to show how to derive these functions, but what we see here is we have root of pi over 2 root 2 minus 2 sine over quarter times root pi over 2 root 2. So that and that cancel, that and that cancel. So in other words, we have root pi over 2 of cosine over quarter minus sine over quarter, right? And that means that our original integral from 0 to infinity of sine of x squared plus x plus sine of x squared minus x is equals to root of pi over 2 cosine over quarter minus sine over quarter. And that's the answer. So without much ado, that is actually what we were aiming for. I will leave a link to show how we are able to solve the integral of cosine x squared from 0 to infinity and sine squared x squared from 0 to infinity. Just for those who may be wondering, but that's a well-known integral. But I hope this helps you kind of grasp what was needed here. With that, we come to the end of this video. Until next time, bye-bye.